We have another earthquake swarm going in Italy at Campi Flegrei. And before we go any further, I want to show you the earthquakes because just today we had another 3.5 guys. So this is significant, but in order to understand what is happening at Campi Flegrei right now, and we know they're meeting again today in Naples to discuss these alert levels, the additional alert levels that they have decided that they would make. I'll get to this later in the video. It's kind of strange, but they're meeting again. They're meeting in Rome, they're meeting in Naples instead of raising it. That's what I think. But they have released the INGV bulletin for the month of February, where we had over 1,800 earthquakes with just one day that had 800 earthquakes, and that was really significant. And in that bulletin, guys, that's why this video is getting longer, but I will explain these graphics and these data that they're giving us, and it's mind-blowing because they're showing us what's going on underneath the ground at Campi Flegrei, and that is crucial to understand. This is a very, very, very good bulletin. So if you are interested in what's happening at the Campi Flegrei supervolcano, stay with me during the length of this video. Get a cup of coffee or something stronger, but let's start with the earthquake swarm, guys. So look at this. So bang, we just had another 3.5 epicenter in the same area where we just had the 4.4 that was shaking, way more violent than the 4.4 last year. And look at this, we have a continuous earthquake swarm basically for over a week now. Has this ever stopped? This is terrible for the people. And I show you the epicenter of the 3.5, and then I'll show you the epicenter of the 4.4, and both epicenters in the same areas around the Solfatara, the most active area where we see most of the epicenters. And these are only the ones above magnitude 1, so there were way more earthquakes. But let's have a look at the epicenter of the 2.6 earthquake, and that is a little bit west of Pozzuoli. It's nothing that is unusual because this is part of the Campi Flegrei super volcano with many calderas. It's in the area of Monte Nuovo. That's a mountain that was formed in the last eruption, in the 1500s eruption. So that is interesting that it's rumbling there. But most of the other earthquakes are concentrated around Pozzuoli, Peschiarelli, and the Solfatara. This one is interesting. It's a little bit of an outlier. So in order to understand that, let's start right away with the bulletin. Campi Flegrei has a way more dangerous, eruptive, and explosive history than the scientists previously thought. That means it's erupting more often. It has erupted more often. They found traces and evidence of another eruption 109 years ago. I've just released a video with details that you really should watch. I'll put it in the end screen. But now we want to look at the monthly bulletin that the INGV releases. They're the ones that are surveilling Campi Flegrei on a regular basis. And what they have released here is interesting. So stay with me. So let's have a look here. This is the area that we're dealing with. This is Campi Flegrei, and they're giving us at the beginning an overview of how many surveillance stations they have there. It's one of, if not the best monitored volcano in the world because it is so dangerous. So they have like permanent seismic stations. These are the yellow dots. And then if you look at the yellow stars, these are tide gogs so that they can see what are the water levels doing, because the land is rising through this Brady seism here, and especially in the port of Pozzuoli, the land has risen so much that the fishermen have problems to get in and out of the port of Pozzuoli. Actually, the grass is growing inside the water basin of the port on the edges of the seawall. So they need to wait. Most boats need to wait for high tide to even get out and in. But even that has become difficult. So they have these tide gogs also in the Gulf of Pozzuoli, they have them here, of course, Pozzuoli, to see what's going on with the land rise. And the same, they have these permanent GPS stations to see what's the land rise doing and where is it going. And you see how many they have, of course, many here in the Pozzuoli-Peschiarelli area, because there is this most active crater, the Solfatara, where we have most epicenters of these earthquakes. But guys, we really have to understand what February has produced. It's like the most earthquakes in 40 years, over 1,800 earthquakes, all in this area. I'll show you the map later. So they have also, of course, here the permanent geochemical stations. They are, of course, close to the Fumarolis, where these gas vents come out to measure like CO2 and sulfur gases. And good thing is they also have stuff in the water that always gets damaged by boats anchoring and hitting these buoys that are there for these ground measuring stations. They thought that this is intentional for a while, so quite strange. But it gives you an overview that we really have a very good surveillance of this volcano, and still there's so much unknown and there is so much risk because of the unknown. But let's have a look what they further say. What they're showing us here in figure 1 is the permanent seismic network that spans over Campi Flegrei. So you have just taken out the seismic stations. It consists of 27 land and marine stations, and it is supplemented by 5 mobile network stations that also do continuous transmission. And they also have permanent marine infrastructure for experimental multi-parametric monitoring and research operating in the Gulf of Pozzuoli, and that system is called Medusa. That is an interesting name, right? It consists of 4 geodetic buoys and an equal number of underwater modules that are equipped with geophysical, oceanographic, and multi-parametric instrumentation. And that's what I mentioned. These buoys get damaged and they're throwing the anchors in this area, which is quite stupid, because if you're there as a boater, you also want to have the warning if something happens, because Campi Flegrei can also erupt in the water, cause a tsunami. And if we're all on top of it with your boat, they just found another ancient crater in the water, so not good. And then they're giving us here in table 1.1, they're giving us the registered number of earthquakes, and they also show us the maximum magnitude. So this is for all February, and they had like 89 earthquakes in the Solfatara-Peschiarelli area with a maximum of 3.2, the maximum magnitude. And then they had like 8 above 0 in Pozzuoli on just February 11th. 1.8 was the maximum magnitude, and then on the 12th of February 15 above magnitude 0. That's a lot for Campi Flegrei. We haven't seen anything that big in the last 2 years that we're monitoring this. 1.7 also Pozzuoli, and then 41 on one day on the 12th, maximum 2.6 Solfatara-Peschiarelli area, and then on the 13th 50 earthquake with 2.8 maximum in the Solfatara-Peschiarelli area, which is high for a volcano. And on February 14th, 11 with 2.4 as the maximum in the Solfatara-Peschiarelli area. So on top of the volcano, on top of where we have the steam vents coming out. And on the 15th, 800 with maximum 3.9 Solfatara-Peschiarelli, Pozzuoli, and Gulf of Pozzuoli. And on the 20th, 31 earthquakes, maximum 2.3 Solfatara-Peschiarelli. So, and then on the 21st, 27 with maximum 2.1, also Solfatara-Peschiarelli Academia. But that is crazy. February 15th was absolutely crazy. If you imagine that the maximum number per month was roughly 1,830 earthquakes, and 800 just in one day, with a maximum of 3.9. So this massive number of earthquakes that has been recorded during February this year, 2025, is currently the highest monthly event count recorded since the resumption of this Brady seismic phase in 2005, but is also as well the highest in the last 40 years. So during February, some events with low resonance frequencies like 2 to 3 hertz were identified, sometimes overlapping with volcanic tectonic events located in the academia area at shallow depth. So they also made a detailed analysis that has proven that the fluids involved are hydrothermal in nature. And they're saying that what we're seeing or what we did see in February exhibits characteristics to those that have been recorded last year in May with the 4.4, but also in August 2024. And then here in figure 1.2, they're showing us the spectrograms of the vertical components from certain measuring stations for the most energetic events that took place. And what is this? A spectrogram is basically a visual representation of the frequency content of a signal over time. And it's commonly used in seismology and acoustics and signal processing, and it analyzes vibrations, sound, or seismic waves, and in our case the seismic waves. And if you look at the x-axis, that represents the time, and the y-axis represents the frequency that is measured in hertz here, and the color intensity represents the amplitude or the power at different frequencies, and with brighter colors typically indicating stronger signals. So what this helps the scientists is that it helps to analyze different types of seismic signals, including like volcanic tectonic earthquakes, low frequency tremors, and hydrothermal activity. And they're used to identify the changes in the seismic energy, and they also want to locate sources of fluid movements beneath the Earth's surface. And if we have low frequency, as they mentioned, between like 2 and 3 hertz, that can indicate the movement of magma or hydrothermal fluids, as we just seen, right? So we definitely do have some spikes here in these graphs. And then they're giving us these interesting bar charts. So the first one that I want to show you, that's the one on the left. That's the number of events that have been recorded at Campi Flegrei over the last 12 months. And that's a total of 8,244 events. That is massive. Not as massive as Santorini, that basically produced roughly 25,000 earthquakes in just a month. But for Campi Flegrei, very, very impressive. And then the other bar chart on the right, that's the number of events that occurred in the last month. In February, in only 28 days, a total of 1,813 earthquakes. So I think this illustrates how significant the month of February was for Campi Flegrei. And that's why they're now have met in Rome discussing changing the alert levels. Now they have added 2 more alert levels, basically, in my opinion, to avoid raising the alert level to orange. So now they have like dark yellow and dark orange. We will see what they will do, if they will at least raise it to dark yellow. Then they're showing us in figure 1.4 an interesting overlay from the hypocentral location, so the epicenter of the earthquakes, how they spread out over the Campi Flegrei volcano over the past 12 months in blue. And then in the last month, that's the red dots. And the symbol size is proportional to the magnitude. So the larger the magnitude. And in figure 1.5, they're showing us the depth of these earthquakes, where the epicenters were, at what depth were these events recorded in the Campi Flegrei area over the past 12 months. Again, on the left side over a 1-year term, and then on the right side is just over the last month. And we can see they are very, very shallow. Many of them range basically from 0 to maximum 4 kilometers. And we know last year a study confirmed that there is a magma chamber at a depth of 3.9 kilometers. So, and then we see really the cluster around February 15th when we had these 800 earthquakes. So it's not a big difference compared to the yearly stuff, but it's a little bit more shallow maybe compared to the yearly chart, but basically they're all in the same area underneath the Solfatara, Peschiarelli, Pozzuoli area. In figure 1.6, and that is for me very, very interesting, they're showing us the magnitudes of the earthquakes that have been recorded at Campi Flegrei over the last 12 months, that's on the left, and then compared with the last month on the right. And you see, if you look at the yearly chart in May 2024, this is when we had really high magnitudes with the highest so far in over 40 years, the 4.4. But also, again, February 15th, they have at least 2 in the 4 range. And don't forget, I think it was the 3.9, but it's plus minus 0.3 error. So it could easily be a 4.2 as well. And we have 2 that high up there, and we have a lot in the 3 range, and it's very strong between like 1 and 2. And of course, then in the lower ranges, it's not too much of a difference when we look at the yearly chart, but it's definitely a spike when we look at towards the 4 range, and then the number of the earthquakes, the sheer number of these earthquakes, that is what stands out so intensely. And we also see the cumulated energy that has been released. And it was interesting in Santorini when a scientist told us, well, when this earthquake swarm was happening and it was at the peak, it said, well, already if we add the energy of each earthquake together, the whole cumulative energy of all earthquakes together matches the strength of a single 6.1 magnitude earthquake. And here we see over the year, it starts basically in March 2024 on the left side, and it's going up, and then January 25, and then we see a huge jump in February. And also in May 2024, we saw that huge jump because we had the 4.4 there. And then on the right, it shows us basically what has happened during February. And of course, again, February 15th, we see that huge jump in cumulative energy because we started seeing these higher range earthquakes. And then they're showing us a table that basically is what we have already seen in the bar charts. So everything that's so smaller than 0, like microseismic, 23%, 417 earthquakes. And then between 0 and 1, 1,028, 56.7%. So most of them, but also between 1 and 2, 220 earthquakes. That's a lot for February. It's crazy. 12%. And between 2 and 3, 43 in 28 days, guys. That is a lot. And for the ones that are following my channel, and if you've watched what I've reported the last 2 years, you will understand this is massive. So it looks small with 2.37% because there were so many in the smaller ranges, but this is huge. And then above 311 in just 28 days, that is a lot. And then the ones that they can't determine is 94. And then let's have a look at figure 1.8 and 1.9. That is very interesting. We haven't looked at that in the past too much. That is the analysis of the focal mechanisms of the most energetic events that have happened in February 2025. So it indicates a reverse faulting mechanism for the big one, for the 3.9 earthquake that happened on February 16th, 2025. It was located in the Gulf of Pozzuoli, and then a normal faulting mechanism for the magnitude 3.9. We had 2 on February 16th in the evening at 11:19 p.m. That we see in figure 1.8. And then we had for the following earthquakes also magnitude 3.2 February 5th, 3.0 February 16th, 3.1 on February 18th. So what is that? It looks quite interesting. It looks like balls. So we need to know the focal mechanism of an earthquake that basically describes the way faults or earth moves during the event. So that's why it is represented with these, it's called beach ball diagrams, which show the orientation of the stress, or if there's a fault, the fault slip. So the analysis of the earthquakes that we had in February have revealed two main faulting mechanisms. So that doesn't mean that we have a fault line underneath or anything. We have reverse faulting, a compression. That was on February 16, the afternoon 3.9 earthquakes that happened at 2:30. It was located in the Gulf of Pozzuoli with a mechanism that is called reverse faulting compressional. So the earthquake occurred due to horizontal compression, where one block of rock was pushed up over another. And this suggests, and that's why it's so interesting, a pressure buildup from below. The volcano is pushing. Could be due to magma movement or hydrothermal pressurization, or both. It could indicate an increase in volcanic activity or ground uplift in the area, which is the case. And then for the other events, we had normal faulting, meaning an extension. And that was happening for multiple events, like February 16th, the 3.9, February 5th, the 3.2, February 16th, the 3.0, February 18th, the 3.1. So a normal faulting, a tensional mechanism. That means the earthquakes occurred due to an extension where the crust was being pulled apart, because we have the land is rising, it's getting brittle, it's being pulled apart, there's magma and hydrothermal fluids accumulating. So this is a sign that a weakening or a stretching of the crust, the caprock layer that keeps the lid on, is happening, very likely linked to rising magma or gas movement beneath the surface. And we know that since the 1980s, that crust is way weaker, only has a third of its strength left. That makes the situation more dangerous even. So it could indicate areas where fractures are forming, which then may allow fluids or magma to migrate upwards. So these areas are very, very important, because Campi Flegrei is a super volcano, guys. It is. The INGV has defined it as such, and the Vesuvius Observatory as well. So there's always comments, it's not, it is, guys. The ones that are having all these measuring stations that are surveilling it on a millisecond basis, they say that. And of course, it is active and it changes seismic activity, ground deformation, and also its fluid movements. And that's why it needs to be so closely monitored. So to find the slightest sign of a potential unrest eruption. And reverse faulting suggests increased pressure from below, and normal faulting suggests crustal stretching, which could allow magma or gases to escape towards the surface. And we have both, right? So the combination of a high earthquake frequency and different faulting mechanisms could indicate a changing stress field and potentially be linked to volcanic activity. That's why this is so important. So this is very interesting what they're showing us here, because it gives us an overview what has been happening since 2005, since that current bradyseism has started again. And this is the trends of the main seismological parameters since 2005. So we see the event occurrence frequency, the hypocentral depth, the depth of the epicenters, the magnitudes, and the cumulative energy in these four pictures. And we see everything is going up. It's a progressive increase in seismic activity that can be observed since 2005, and both in the number of events and also an increase in their magnitudes. That is really, really intense if we look at that. And you see figure A, the number of earthquakes, right? It goes, and there you go. In 2025, that's that spike. That's February. That's what we're talking about right now. And then number B, that is the depth of these epicenters. They're showing this just for 2025. We've seen this picture again. And then we see in number C, that is the magnitudes that we're seeing. And there you see it's really increasing in magnitudes, but it's also getting darker the closer we're getting to like 2020. Already starts getting dark at 2017. So not only are the magnitudes going up, but also the number of earthquakes. That's why it's getting so dark. You can't even make out single dots anymore. And then of course number D, that's the cumulative energy. And there you really see that this is exploding basically after 2021, and especially in 24 and in 25. So anyone who says that Bradyseism that we're seeing here, that is normal, it has always been like this, should better listen to Giuseppe Di Natale when he says, no, this is not normal. Usually Campi Flegrei is quiet if it's not before or after an eruption. I've said it before. So very, very interesting graphs and comparisons. And here this is interesting because they have singled out the events over magnitude 3.0 since 2019, since it became significant. So they're showing us the locations and the trends of these main seismological parameters. So picture A, that is the event occurrence frequency, the frequency of the earthquakes. B is the hypocentral depth, the depth of these earthquakes. C is the magnitudes of these earthquakes. And D, again, is the cumulative energy of these earthquakes. And again, we're seeing the trend here, especially in the cumulative energy, going up. And in 2024, we had a lot of earthquakes above magnitude 3, but don't be fooled by the lower bar in picture A in 2025, because this is basically just for the first 2 months versus the higher bar for 2024, that's for 12 months. So if this continues like this, the 2025 bar will be a lot higher. And then we also see in picture C, most of the earthquakes above 3.0 were happening 23, where we also had some 4.2 at the end of 23, and then 24 and 25. But again, 25 has just started. So something is really accelerating. And guys, the next graph, when I saw that, it really hit me. That's figure 112. It shows us the frequency of occurrence of earthquakes recorded at Campi Flegrei since 1983. And it shows us the corresponding cumulative energy. And we know there was this magma intrusion in the 80s. And we know that since that event, the caprock layer that keeps the lid on, that keeps the magma underneath the ground, has only 1/3 of its strength left, because the rocks were getting brittle by all these Brady seismic events, and it was stretching out. And that's why it was so important that we've seen these balls where we see what's happening with the crust. Black line represents the cumulative energy if we look at these charts. So the cumulative energy, if you compare it with the 1980s and you compare it now, how much that has spiked. It's crazy. So we have less stability in the caprock layer, only 1/3 of what we had in the 1980s when the cumulative energy was way lower. And also we see like it's a spike in 2025, but already in 24 and in 23. So that is exceeding the event of the 80s, and 2025 again has just started. So where is this going? That's why so many scientists are saying this super volcano is creeping towards eruption. Hopefully only phreatic, hopefully small, but this is above normal. And then they're showing us the locations of their permanent GPS stations spread out all over the Campi Flegrei volcano, from Monte di Procida, Pozzuoli, Quarto, even right in western Naples. And they have detected, and they're showing us this graph, that there is an increase in the land rise. You see this on the right side of this chart, these blue lines. There is a significant increase. And we already had that in the events, when the events happened in May 2024. There was also increasing to 2 centimeters a month. Then after a few weeks, it was going back to 1 centimeter a month. Then we had February 15th, 16th with these 800 earthquakes. The land rise was accelerating to 1 centimeter per day, not per month. And now it seems that it's at 1.5 centimeters per month. You see the increase. And then they're showing us the graphs, the same increase in various measuring stations. So that confirms kind of that it's not a random error. And they're showing us the locations of these measuring stations. So if you look at the first one on the top left, that's the right station. There the curve is the steepest. That is Pozzuoli. That is the center of that Brady seism. And I show you the picture here of the port of Pozzuoli, where the grass is growing along the seawall, where there should be water, where the boats are running dry. And since November 2005, the total uplift that is recorded at that right station in Pozzuoli is approximately 1.40 meters. So 1.5 big steps. And 22 centimeters, that's that much probably since January 2024. So that is a lot. That's why it explains why they're having the problems in the port. Versus Grindavik, through the events, the port was, the ground floor lowered. So they actually have a deeper port now, where they said, well, that's at least one advantage of the whole stuff. And again, if you look at that curve, if you look at that black line, if you start visualizing what's really happening at Campi Flegrei, then tell me that this is not heading towards something critical. Figure 2.1.5 is also very interesting. It basically shows us the map of the displacement vectors for a horizontal movements and vertical movements. B is vertical movements, A is horizontal movements that have been recorded at these GNS stations in Campi Flegrei since only 2023. So there we can see, is it vertical uplift, but where is it going, in what direction? And so this radial pattern of that deformation field has these bell-shaped uplift characteristics, and it's confirmed by these images and by these measurements that this is still like a bell-shaped uplift. And this is basically the same pattern that they have observed in previous uplift phases, like in the 1980s. And guys, understand, in the 1980s, magma was getting out of the magma chamber that was filling up underneath. It was causing an intrusion, like an intrusion that happened in Campi Flegrei in November that was doing so much damage. So it didn't reach the surface, but it was getting out. It could have. So they're saying, if you look at picture A and B, that indicates the stability of the deformation source. What is the source of deformation? Most likely, it's a magma body that is coming up, that is growing. And it's, if they see how this deforms, it's located a few hundred meters south of the right station. I've reported about Monte Obliano just recently, where we do not see such a rapid increase like in the other areas. So they call this a local anomaly in the Accademia Dome. That's the Monte Obliano area. And it still is existent as it's previously been reported in the past bulletins. That's just as a side note. And if we look at the vertical deformations on the seafloor in the Campi Flegrei caldera, that is recorded by that Medusa system since January 2023. That is shown in figure 2.16. And the GNSS stations that are positioned where these buoys are in the Gulf of Pozzuoli are within the area of maximum deformation. So there's a maximum uplift about 1 centimeter that was recorded during February 15th to 19th during that seismic swarm. And the total uplift since 2023 has approximately reached on that seafloor area 30 centimeters. So something like this. Then they're showing us the locations of their tilt measuring stations. So where is the ground moving in which directions? That's the ground tilt monitoring network of Campi Flegrei. They're having 10 stations there, 4 stations equipped with surface analog sensors, that is by SLF, OLB, and CSO, 3 stations with analog borehole tilt meters, that is PSC, RRC, TOI, and they're installed at depth between 1 and 7 meters. And then they have 3 stations with digital borehole sensors, that's CMP, ECO, HDM, and they are installed at a depth of 25 meters. So they're really surveilling that ground there, and they have high resolution of these borehole tilt meters, and that allows them the detection of ground tilt variations that can be linked to seismic events, local fluid migration in like highly fractured areas, or like main deformation field variations due to the ongoing uplift, the land rise in the Campi Flegrei caldera. And then if you look at graph 2.2.2, that are the time series and the plots from March 2024 to February 2025 of the tilt that was recorded by the digital borehole stations, ECHO, HDM, and CMP. So the signals that you see in these graphs have been filtered to remove diurnal and semi-diurnal tidal components that might have an influence on that. So what these diagrams specifically represent, these curves, if you look at picture A, that's the north-south component. Increasing tilt values over time indicate ground inclination is shifting northward. And then if we look at the chart at B, that's the east-west component. And also increasing tilt values over time indicate ground inclination is shifting eastward. And then we have number C, that's the tilt vector representation over time, showing the overall direction and magnitude of ground inclination changes. So what you see here in this graph, or in all 3 of these graphs, especially the signals that they recorded at the ECHO station, indicate an overall ground tilt in the northwestern direction. We had several offsets that were detected in 2024 that did coincide with the most energetic seismic events. That's why it's not a gradual curve. And during February 15th to 19th this year, 2025, that seismic swarm with the maximum earthquake 3.9, an additional offset was recorded shifting in the southwestern direction. Guys, I hope you're still with me. Maybe it's time to get another coffee, but this is really very interesting, and I promise you more interesting charts are on the way. I know this is long, maybe watch it in 2 parts, but if you can watch it in one piece, of course, that is better for my channel, for the algorithm. So please watch it. I promise, guys. It took me 2 days to work on this video, but I wanted to really translate and explain that whole bulletin for you guys. So look at figure 2.2.3. The signals that they have recorded at the HDM station indicate a ground tilt in the eastern direction throughout 2024. And then in April, May, and June, slight tilt variations were recorded because there were, again, these seismic swarms in the area. And then August 2024, an additional tilt shift towards southeast was observed. And then in August 17th, 18th, and December 6th, 2024, well, we had seismic swarms. A rotation of the tilt vector towards southeast was detected. So something is really moving around. And then now, just during February 15th to 19th, that seismic swarm was causing small variations in the ground inclination that was also recorded. That's why these curves look so weird, because we have these seismic swarms. In figure 2.24, that's the CMP station, overall ground tilt in the north-northwest direction. That's what this is showing us. In figure 2.31, they're showing us the tide gauge monitoring. It's called Gravimetric, mare, the sea in Italian. So the tide gauge network of Campi Flegrei consists of 5 stations that are equipped with instrumentation based on a shaft encoder system and radar technology, so they can measure what's going on in the sea. Figure 232 presents the tide gauge data that were recorded at the Pozzuoli port station in the port of Pozzuoli, and that has indicated an uplift there of approximately 102.6 centimeters. So that's a meter, a big step that you take only between January 16th and February 2025. So these are the vertical ground movements between 16 and 25 that they have obtained through the analysis of the data that were recorded by this tide gauge station, Pozzuoli Port, POPT, that is basically located in the central area of the Campi Flegrei caldera. And these are daily variations, daily averages expressed in centimeters, and they're also referenced to the Naples tide gauge station. And seems they have an area in between where these were damaged or out of order or whatever, because there is nothing visible in the curve. And then they're giving us a broader overview, basically what has happened at the port of Pozzuoli since the Brady seism started. So tide gauge data from January 2006 until now, until the big event, February 2025. That's figure 2.33, the vertical movements at the port. And what we can say is that they have recorded a ground uplift of that port. That's why the problems are there, of 135.1 centimeters. That's a lot. And then if we look at the next figure, figure 234, that's the data that are recorded by all tide gauge stations in the Campi Flegrei area over the period January 2006 until February 2025. And there you see the strongest uplift is definitely recorded, the red line, the top line, the POPT station at the port of Pozzuoli. Figure 2.41 shows us the gravimetric network, and it's very interesting. If you look at the yellow point that represents the absolute reference benchmark, it's located at the monumental complex of Lago San Marcellino in Naples. And between February 2nd and the 11th this year, 2025, they have started a new measurement of relative gravity measurements in the Campi Flegrei area, and it was taken at 39 network stations. We see the stations here in this figure, and the relative gravity measurements were carried out. They have used, it's called a Skintrax CG6 gravimeter, shows us it's corrected for like solid earth tide variations, atmospheric pressure changes that might influence these measurements instruments, or just an instrumental drift. And then they're showing us figure 242. It presents the observed gravity differences, which have not been corrected for the contribution of ground uplift that's recorded between October 24 and February 25. So the maximum uplift at the right GNSS station during this period was approximately 4 centimeters. And what the conclusion of this is, the gravity variation field shows a clear asymmetry in the academia area, and we've seen a lot of earthquake epicenters in the area where there is a persistent uplift deficit that has been recorded there, the Monte Obliano anomaly, and that has been observed for several years if you compare it to the surrounding areas. In figure 243, we're seeing variations along the coastline between the port of Pozzuoli and the academia area, as well as near the Solfatara area. And if we look at figure 244, they had concluded the February gravimetric survey on February 11th, but then we had this increase in seismicity, this seismic swarm from February 15th to 19th, and there was significant cumulative energy release. So they have done an additional gravimetric survey between February 24th and 27 at 20 stations, primarily located in the central sector of the caldera, to verify any gravity variations that might be related to the seismic swarm. And that's what we're seeing in figure 244. Basically, they compare the pre and the post-swarm surveys. So the map shows modest variations, borderline significant from a statistical perspective, that's what they're saying, with increases detected in the Astroni Solfatara area and around Monte Nuovo. And you might want to ask, okay, looks interesting, but this gravimetric survey, what does that tell us? What is that useful for? Well, we want to find gravity anomalies, like differences in gravitational acceleration caused by variations in underground mass distribution. And that is very, very important if we have a volcano underneath. What are the ground deformation effects of that? So gravity can change due to a ground uplift or subsidence. We have mass and density changes that we want to observe. Like in volcanic areas like Campi Flegrei, the gravity variations that they find there, they can indicate magma rising or accumulating underground. That's why this is so important. Hydrothermal fluid movements, fractures or voids forming in the subsurface. So if we find something like this, it shows us Campi Flegrei is alive and something's coming up. That's basically what this tells us. So basically in early February, before that earthquake swarm happened, they had a good baseline with that first survey. And then that strong seismic swarm occurred that was linked to processes going on underground. And then post-seismic swarm, when they conducted that second survey, they wanted to detect the changes in gravity due to magma or fluid movement that might have happened during that swarm. So especially then what comes out of that is that in the Astroni Solfatara and Monte Nuovo area, there is a subsurface mass redistribution. And again, we have a normal gravity field that can be before a magma intrusion. We have a gravity increase, that means magma rises. It creates an increasing subsurface mass. We have a gravity decrease. For example, magma drains or creates voids underground. That's not the case right now. So when they're talking about subsurface mass redistribution, that refers to the movement, the addition, in our case here, addition or removal, but here the addition of material beneath the Earth's surface. And that's what we're measuring here, because that leads to the changes in gravity, the ground deformation, and the seismic activity. So if magma is rising from deep underground into a shallower magma chamber, like it does in Iceland as well, this increases the local mass. So we have higher gravity readings. Ground uplift that we have in Campi Flegrei, we have increased pressure, potentially leading to more earthquakes or even eruptions. That's why these measurements are so important for trying to forecast something. If we have hydrothermal fluid movement at places like the Solfatara in Campi Flegrei, where we have the Fumarolic, the hot water, the steam, and the gases that are moving through cracks and fractures that are in the crust, these fluids increase the mass. Okay, they can decrease it too, but locally they increase the mass. So the gravity, surface deformation, and seismic activity increases. So when we look at this graph again, 244, we have these black dots there. They represent the stations that were remeasured between February 24th and 27th after the earthquake swarm stopped. And then they calculated the gravity differences relative to the earlier results from February 2nd to 11th. So the two areas between the Solfatara and Astroni and near Monte Novo show positive gravity variation. So something is increasing underneath. And then they're showing us figure 245. That's the long-term gravity trends from 2015 to 2025. And what they have done to analyze long-term gravity variations, they have done a time-lapse gravimetric data set for the last 10 years. They have focused on stations that were able to deliver them continuous data. They have also used satellite Sentinel-1 data on vertical ground displacement to see if the ground is rising. So the key findings that they have over this period of time are shown in this graph here, 245. It's the time series of gravity variations that they examined for the stations in the central caldera in the area of interest, the Solfatara, Arco Felice, and La Pietra, and at Palazzo Reale, which is a little bit outside of the caldera. So the black line, it has also error bars, is the observed gravity data. Then we have the red line, that's the gravity contribution from uplift. That's what they have gathered from the INSAR satellite data. And then we have the blue line, that's the gravity residuals. They are calculated as the difference between the two data sets. So what they're saying is the observations is that they have multi-year residual variations detected with varying amplitudes, and long-term positive trends were observed, with the highest at the Solfatara, then Arco Felice and La Pietra, and then Palazzo Reale that was outside the caldera had no significant variations detected. So these positive residual trends suggest a volume increase in the source that is causing that unrest, which is driving the uplift, so the magma. And they are estimating, and we learned that already last year, they still call it the source of the unrest. I would call it the magma chamber, is estimated to be located at approximately 4 kilometers of depth. So not very deep, guys, very, very shallow. It's slightly south of the port of Pozzuoli. And right now, as we speak, further studies are underway to determine what that source of unrest is. Is it just hydrothermal, fluid driven? Is it magmatic, magma accumulation? Is it hybrid, magma and fluids interaction? But a special study last year has found that there is a magma chamber at 3.9 kilometer depth. In 2.5, they're showing us the Dilatometric network at Campi Flegrei, and it consists of 4 acquisition sites. And what is that? What do they measure? They're measuring the local strain field variation. That are basically the changes in the deformation of underground rock layers, and that's important for a volcano like Campi Flegrei. Dilatometry is basically measuring small changes in the volume or strain, the deformation, so to speak, of the Earth's crust over time. And that is super, super important for Campi Flegrei. And this technique is crucial in volcanology and geophysics because it helps the scientists that are surveilling Campi Flegrei to detect underground stress and pressure changes. And if you want to be able to predict a potential volcanic eruption, to at least have a little bit of a warning time, this is what you need, because it can signal magma movement or impending eruptions. And that's why it's so crucial that we look at these data. A dilatometer and is also an extremely sensitive instrument, as you can believe, so that it can record the smallest changes, and it measures how the ground basically expands or inflates, like we have here this land rise at Campi Flegrei that has accelerated. The bulletin just came out, 3 centimeters per month. From 1 centimeter, it went up to 1.5, and they thought, the 1.5 might just be a measuring error. 3 centimeters, guys, per month. That's the biggest acceleration we have seen at Campi Flegrei. So this is important. And since now it's day 4 of making this video, I can give you all the latest updates. And also, like, a massive earthquake swarm was taking place on just today with 3.0 again. And I have made a detailed video about the latest land rise and this earthquake swarm. It's in the end screen of this video. You should watch that as well, or maybe you're coming from that video and watching this one. They have a dialometer. It's called the Eruption. It's used at Campi Flegrei. It is installed in a borehole, in deep boreholes as deep as 120 to 180 meters. And of course, they're doing this to avoid like surface disturbances, like weather, wind, storm, or human activity, because they're so highly sensitive. So, and then they measure the strain. With the strain, what does that mean? They mean like tiny changes in rock volume. And if something's rising up, you know, that's what we have been trying to figure out with the gravity measurements that I just talked to you about. So it has a huge precision of 1 part in a trillion and a wide frequency range as well. And the recorded strain is dimensionless, meaning it represents a relative change in the Earth's crust rather than an absolute size. So since we have the land rise, since we have these earthquake swarms, the Dilatometry is monitoring the magma movement of Campi Flegrei. If magma rises, the ground inflates, and this is recorded. It detects the fluid migration. Is the hydrothermal system, are the fluids there moving underground? It can also cause measurable deformations. It tracks stress accumulation underground. Very important. So strain changes can indicate a fault activation or crustal weakening. Crustal weakening is the important thing here at Campi Flegrei, and that can be measured before earthquakes or eruptions, and therefore improve early warning systems. So together with all the other surveillance networks, it helps the scientists to get a broader picture. Let's look at this graph 252 here, the strain time series. So the strain are these measurements. That has been recorded from February 1st, 2024 to March 3rd, 2025. And picture B is the strain recorded over the past month from February 1st, 2025 to March 3rd, 2025. So both are very interesting in light of what just happened. So we see this in picture A, it's going up. And then we see over the last month also we see that something is happening. And then keep in mind the gravitational changes, the recorded acceleration of land rise. Keep in mind the curve that I just showed you, where we have compared to the 1980s, what was the curve compared to now, how it has accelerated. And then there's another graph, figure 2.53. That is a detailed analysis of the strain at the Quarto station. So figure C is detailed strain variations recorded by the Quarto station during the earthquake swarm last month, during the 15th of February till February 20th, only the ones with magnitude larger than 3. And then you see these dashed vertical lines. They indicate the occurrence of seismic events with a magnitude greater than 3. So what are the key observations that they're giving us from this? So the Quarto Dilatometric station shows co-seismic strain variations. So both show that associated with the February 25 seismic event. The largest strain change occurred, of course, during this big earthquake. So there's a relation, of course. The magnitude 3.9 earthquake on February 16th, the one that happened in the evening. We had 2 3.9 on that day, but the one in the evening, half an hour before midnight. But after these events, so far, no more additional significant strain variations, but this is just new, and this has not been incorporated in this analysis that the land rise has accelerated. So I'd be surprised if we didn't see some new variations there. Now look at figure 311. This is extremely interesting. You see an aerial picture of the Solfatara. This is what I'm showing you so often as background pictures. This is the area where most of the epicenters are happening, around that area. This is where we have the Fumarolic, the hot steam, the bubbling mud pools. This is where the most gases are coming out, and they have thermal images there, and they're showing us the images. And this is amazing to see because, you know, there you see what is going on. So they have permanent thermal imaging network stations at the Solfatara network. They have the SF2 station, and this is basically capturing nighttime infrared thermal images. And it monitors the northern sector of the inner slope of the Solfatara crater. And then they have the PS1 station that records the thermal images of the upper western slope near the main Fumarolic at Peschiarelli. So the red dots indicate the camera positions. The yellow areas represent the observed thermal monitoring zones. And then let's have a look at two charts. So figure 312, SF2 station, and 313, that's the PS1 station. They show the processed time series and the maximum temperature values from these infrared images that they have acquired from both stations. And they have processed these data, and they have used seasonal trend decomposition as an algorithm to remove seasonal variations, like something that could influence weather, outside temperatures and stuff like this. And then they have obtained long-term trends. They have basically applied a second degree loss fitting to de-seasonalize maximum temperatures like rain, cold, differences between summer and winter. So we're looking at the figure 312, the SF2 station. So the time series of maximum surface temperatures that they extracted from the infrared images. We see the weekly averages, that's the blue line. We see the long-term trend, that's the red line. That was retrofitted with the second degree LOESS system to rule out weather influence. And in February 2025, they're giving us their key finding. They're saying the temperature trend shows strong fluctuations but remains generally stable. The long-term trend, the red line, they say confirms no significant changes in surface temperatures. So no significant changes, but a slightly elevating trend if you look at between 2024 and 2025, but also between 23 and 24. It's not as drastically as other measurements that we see, but it's still there. And if we look at the other station, the figure 313, the PS1 station, processing was similar. Weekly averages blue line, long-term trend red line. Maximum surface temperature values remain generally stable throughout February. However, the oscillations have increased in the second half of the month of February, so after or during this earthquake swarm. Long-term trend red line, that's what they say, confirms overall temperature stability. But also we see, if we compare it to where this red line, where the curve starts from 2022 to 2025, it has definitely increased. And then let's have a look at a longer time frame. Figure 314, long-term temperature trend from October 2007 till February 2025 at the PS1 station. No significant changes in February 25. Stabilization of surface temperatures detected in the infrared images. This is what they're saying. And if we look at this, yeah, this is nothing that looks like it's drastically escalating, though we have to say, if we look at since 2022, there is an increasing trend. In addition, they're doing thermal monitoring with mobile thermal cameras, a thermocouple, and a drone. The purpose is also to identify variations in ground temperature at specific measuring points, detect high temperature zones to track changes in this Fumarolic field distribution. And you see in figure 3.321, the thermal measuring points within the Campi Flegrei caldera, they are distributed across various zones on the caldera floor. So in this figure 321, the red dots that you see there indicate the station points where the surveys were conducted. And then we have the thermal imaging areas, panel like B. Its light blue, green, and pink areas represents slopes surveyed using thermal cameras from stations PS1, PS4, and PS5. Then we have panel D, that is yellow, green, and pink areas. They indicate slopes surveyed from the stations SF1, SF2, and SF3. And then we have SF2A and SF1B. They mark specific measuring points using thermal cameras and thermocouples. And then we have panel D1. The pink area represents the thermal camera survey zone from station S4. And the observations that they made in February, no significant variations in maximum temperature were observed. No notable changes were detected in the areal distribution of the Fumarolic field across the different measurement points. But then they have done some site-specific observations for February 25 in Peschiarelli, in Monte Nuovo, and in Agnano Terme. If we look at Peschiarelli, since April 2019, they started primarily using a drone, and there are thermal anomaly areas at Peschiarelli. So the thermal imaging analysis highlights two areas of significant thermal anomalies. At PSD1, that covers slopes previously monitored with handheld thermal camera from stations PS1 and PS4. And then we have that point PSD2 includes the slope that was previously surveyed by station PS5. And temperature trends for February 2025, the maximum temperature values that they detected show no significant changes to the previous month so far. But they have been going up. But they have reported about this the previous month before, so February was no change. Monte Nuovo, they have looked at, remained stable so far, except for seasonal variations because they have used thermal cameras and thermal couples. Same at the Agnano Terme. And this is interesting again. Now we're looking at the geochemistry of the fluids. February 2025. Has been monitored at Campi Flegrei. So continuous monitoring of CO2 flux from the soil. We know many houses had problems, had to be closed down, including schools. Fumarolic temperature and thermal gradient in the Solfatara crater. That is station V03 and stations FLXOV5 and GTS1. They have done sampling of the main fumaroles, the Bocca Grande, BG, the Bocca Nuova, BN, and in the Solfatara crater, and also in one fumarole in the Peschiarelli area. They have done also soil, CO2 flux and temperature measurements at fixed monitoring points in the Solfatara and the Peschiarelli area. And you see in figure 4.1 the location of these geochemical monitoring stations. They have new multi-gas measuring stations. They measure CO2, H2S, SO2, H2O, include a 3D sonic wind sensor, and they're located in the Solfatara Peschiarelli area, and they're still in the testing phase. The green symbols is the Solfatara area and the Pisciarelli area. And the key observations, what we see in figures 4.2 and until 4.6, the hydrothermal system continues to show signs of heating and pressurization consistent with previous reports. So it continues to heat up and to build pressure because something's coming up from down below. And then the CO2H2O ratio in the Fumarolic gases, that's figure 4.2, it remains high in February for both Fumaroles. So they say that this suggests a significant magmatic gas fraction in Fumarolic emissions. What they're saying is, when they interpret these CO2H2O variations, they say there's condensation of steam in the hydrothermal system, and that is influenced by increased magmatic fluid flow and pressure. Boom. Increased magmatic fluid flow and pressure. Where could the CO2 come from that we have in schools and homes? Well, a potential contribution of CO2 from hydrothermal calcite decomposition could be the case, and that could be triggered by rising temperatures in the system because magma is moving up. It's not good. And we can see the trends in figure 4.2 from 1982 until now. And we see, we had in 1982, 1984, the last intense bradyseismic event with a magma intrusion, but it wasn't nearly as high as it is now. And so that is really intense. So you see the white dots, that's 1983 till 99, and then the darker gray ones, that's the 2000s till 2025. And there you see how it has accelerated since the 80s. So if we look at these graphs, what we need to understand is that the scientists at Campi Flegrei have been tracking the CO2 and CH4, the methane gas ratio in the Fumaroles, in Boca Grande, BG, and the Boca Nuova, that's the BN on the map, and Campi Flegrei since the year 2000. This ratio helps detect magmatic degassing, which is very important. And peaks in CO2 indicate increased volcanic gas activity. The key findings that they had in the years from 2018 to 2021 is that the CO2 and CH4, the methane gas ratio, was lower, meaning higher methane levels. And at the same time, carbon monoxide, CO, and hydrogen, H2, increased, which is suggesting changes in the hydrothermal system of the volcano due to rising pressure and temperature. So something's rising up. And this likely happened because they think steam was condensing in the system's upper layers and has trapped the gases differently. The recent trends that they have seen from 2020 to 2024, since the late 2020s, the CO2 CH4 ratio started increasing again, showing a new phase of magmatic degassing. And then we had two minor peaks recorded in April 21 and in March 22, which was leading to the highest point in December 2023. And then by early 2024, the ratio started decreasing, suggesting the end of this peak phase. But there are additional indicators of unrest if you look at all these charts. So the soil CO2 emissions and the ground temperature measurements at the Solfatara show a long-term increasing trend since the bradyseismic crisis began in 2006. They have done monthly surveys and they show annual fluctuations, but they confirm that the CO2 emissions are rising over time. So large-scale degas surveys resumed in 2022. They had been paused since 2016 because there were difficulties accessing the crater. So what does this mean for us? The recent peak in CO2 and CH4 ratio suggests that magmatic fluids were actively moving in the system until early 2024, and the hydrothermal system has been pressurizing and heating over the years, increasing the CO2 emissions that are currently causing a lot of problems in buildings. Schools had to be closed, buildings' basements, people felt dizzy, people felt like they would be fainting. So this is an indication, or it could indicate, increased volcanic unrest. And yeah, we see things increase, right? With this magnitude 4.4 that just happened, with the largest ground acceleration ever measured around the epicenter. So that was massive. Means the shaking was stronger, the strain on the buildings was stronger. So let's have a special look at figure 4.7, the diffuse degassing in the Solfatara-Peschiarelli area. The map illustrates this diffuse degassing, highlighting the target area for their monitoring. And there is figure B, that is a CO2 flux chronogram. And if we look at the blue points, they represent the CO2 emissions from the target area and scaled to the entire diffuse degassing system. That's what it says, DDS. So these values were obtained by the scientists by comparing data from 30 extensive measuring campaigns. These are the red symbols. And the correlation between these measured fluxes in the target area and the extended area allowed them to estimate for 2020 roughly 3,200 tons per day of CO2 flux. And in 2023, 3,500 tons per day. These values are comparable to the average CO2 flux of persistently degassing active volcanoes. But then there were changes in these diffuse degassing patterns. So since 2022, the relationship between extended estimates and monthly flux measurements appears to have changed from what they reported previously. So it suggests a shift in the degassing pattern with a relative increase in CO2 flux within the crater area that they measure monthly, and a decrease of CO2 flux in the external area covered by extended surveys. So this has resulted in a reduction of that scaling factor that they previously had. And then there is a trend for February 2025, the CO2 flux and temperature trends. So they are doing monthly measurements inside the Solfatara. It shows a high CO2 flux, particularly in February 2025. So if they look at the whole area, this suggests a CO2 flux, and here it comes, of approximately 5,000 tons per day. So way more. And that continues the increasing trend that has been observed in previous measurements. And the soil temperature that they are measuring at 10 centimeters depth exhibits a clear seasonal pattern that we see in figure 4.8. So it's superimposed on a long-term rising trend. And between 2002 and 2024, the average measured temperature increased by more than 8 degrees. And then let's have a look at figure 4.9, the spatial temperature increase. So we look at 4.9a shows the temperature increase rates in Celsius per year per measurement point since 2002. So the entire crater area exhibits widespread warming with the highest increase in the central zone. And if we look at figure 4.9b, there's no significant temperature increased in the Fumarolic areas and in the northeastern crater rim. These areas are already high near the physical condensation limit for solfataras emitted fluids at the moment between 95 and 97 degrees Celsius. And if we compare these recent findings with past volcanic unrest phases at Campi Flegrei, because many people always say, well, the 80s was worse. It wasn't. We just heard that even the ground uplift now is 40 centimeters higher than in the 80s. If we look at the CO2 flux and degassing patterns, in 2025, higher CO2 flux with the 5,000 tons per day in February shows a steady increase since 2020. Shift in the design pattern with more intense gas release within the crater and reduced emission in the peripheral areas. The warming of the crater floor, right, consistent with this increasing hydrothermal activity. Warming of the crater floor 8 degrees. And what happened in the 1980s in that crisis from 1982 to 1984? The degassing rates were also high, guys. Don't get me wrong. They did not have these detailed measurements of CO2 flux, though, in the 80s. The rapid ground uplift that happened, roughly 3.5 meters between 82 and 84, was also accompanied by severe seismic swarms, which led to the evacuation of Pozzuoli. People were evacuated, and then only an intrusion happened, no eruption. The hydrothermal system was highly active, but the Fumarolic temperatures in the 80s were notably lower than today. They were only at 80 to 90 degrees Celsius versus like 95 to 97 degrees at the moment and in 2025. So the key difference between the two events is that the 2025 flux is 5,000 tons per day, exceeds estimates for the 1980 crisis. So a greater gas input is happening into the system today. Also, the current warming trend of the crater floor was not seen in the 1980s. And if we look at the ground uplift and the stress accumulation, the ground uplift has in 2025 exceeded the levels of 1984. So overall, 4 meters of cumulative uplift since 1950. So we are right now entering a phase of strain accumulation that we have never seen in centuries, surpassing the thresholds that have been recorded since the eruption in 1538. The 1538 Monte Nuovo eruption, the pre-eruption phase, was from 1430 to 1538. So pre-eruption uplift was far greater at that time, exceeding 10 meters over a century. There was persistent seismicity and Fumarolic activity. It occurred for decades before an eruption. So ultimately, the degassing intensified significantly before magma reached the surface. So can we say that there's a key difference, but every eruption is different? Well, we could see a small thing right now, like a phreatic eruption, not like forming of a new mountain like Monte Nuovo. So today's uplift with over 4 meters is still below the 10 meters recorded before 1538, but the rate of increase has accelerated. It's coming to the surface faster, and we have less strength. So if this trend continues, it could eventually reach the pre-level 1538 levels, and that would pose a serious risk for an eruption, for magma ascending. So the seismicity and the ground shaking, if we compare it to the 80s, so we have in 2025 more frequent earthquakes reaching this magnitude 4.4 in October 24, and now again right now. So strong ground acceleration was recorded and that is right now indicating an increasing strain in the crust. So many earthquakes are also shallow, between 1 and 3 kilometers in depth within the hydrothermal system. And in past episodes, 82 till 84, large seismic swarms reached only magnitude 4.2. And that has led to a lot of structural damage in Pozzuoli. And the pre-1538 eruption, increasing seismicity, was a key precursor before an eruption. So the key difference is today's earthquakes have higher ground acceleration as well than those of the 1980s. The 4.4 with 0.16 had the highest ground acceleration ever measured. Seismicity is shallower at shallow depth, which may indicate hydrothermal pressurization rather than direct magma movement. For now, they don't know. So the 2025 unrest phase is distinct from the 1980s crisis, but it is evolving towards pre-1538 conditions. The combination of high CO2 flux, accelerated uplift, and stronger seismicity suggests increasing stress in the system with a damaged caprock layer. So if uplift and degassing continue accelerating, the possibility of a magma intrusion or eruption in the future cannot be ruled out. And figure 410 shows us a timeline. It's called chronogram of average soil temperatures that were measured at this depth of 10 centimeters from 25 fixed points in the Peschiarelli area since 2009. If we look at the blue line, it represents the de-seasonalized trend. Seasonal temperature variations were removed to allow the scientists to observe long-term warming trends more clearly. If we look at figure 411, presents a map showing the rate of temperature increase in Celsius per year at each of the 25 fixed measurement points in the Peschiarelli area since 2009. The entire area has experienced a temperature rise, confirming this consistent warming trend over time. Highest temperature increases are concentrated in areas with active Fumarolic activity, where also the gas emissions are the strongest. So this pattern suggests that hydrothermal activity in Peschiarelli has intensified, likely due to increased underground heat and gas circulation. And what creates the heat, So the continuous warming in Peschiarelli is a sign of ongoing volcanic unrest, potentially linked to rising magmatic or hydrothermal fluids beneath Campi Flegrei. Figure 412 shows the CO2 flux from the soil and Fumarolic temperature recorded at the Flux OV5 station that is located right inside the Solfatara crater, just a few meters from the main Fumarole that is called Bocca Grande, BG. So the CO2 flux from the soil has significantly increased since 2016, as indicated by the red line that you see there. The red line represents daily averages, and the bottom chronograms display the detailed CO2 flux and temperature variations recorded since January 2022. Also here, rising CO2 emissions, Fumarole temperatures suggest an increase in underground heat and gas activity consistent with the volcanic unrest at Campi Flegrei. And the pictures we see here in figure 413, it illustrates the macroscopic changes in the Peschiarelli emission area from 2005 to the present. So the emission area has expanded significantly over time, likely due to increasing hydrothermal activity. So the visible changes are like widening of Fumarolic vents, and the formation of new gas escape points, increased ground alteration from acidic gas interaction. And what does that evolution suggest? Well, higher underground pressure and greater fluid movement in the hydrothermal system. It's like a pressure cooker, the pressure is going up. So the growth of this Peschiarelli emission area definitely comes in line with the other indicators that show unrest at the Campi Flegrei volcano, like the rising CO2 emissions, the increasing soil temperatures, and the higher seismicity. Like all this, we have a more active and pressurized system. And then here, next picture, figure 415, displays the daily averages, that's the line, and the monthly averages, that's the circles, of CO2 flux that is measured by the automatic monitoring station at Pozzuoli. So we have a continuous CO2 influx since 2007. The data shows a steady upward trend in CO2 emissions over time, also showing that it's an indication for persistent volcanic unrest. February 25 average CO2 flux is marked in red, showing recent values in line with the increasing trend. Figure 416, also chronogram, shows us the daily averages in the line and the monthly averages, the circles, of CO2 concentrations in the air, recorded every 2 hours by the FLXOV8 geochemical station at Pozzuoli. Daily time series of Fumarolic tremor amplitude are also recorded by the CPIS seismic station that is installed near the main Fumarole. It was there until 2023. There is a long-term increase from 2013 to 2021. Both CO2 concentrations in the air and Fumarolic tremor amplitude continues upward trend, indicating increasing hydrothermal activity. There was a temporary decrease after 2021 in both CO2 levels and Fumarolic tremor, but it is suggesting a short-term stabilization or fluctuation in the system, but in the most recent period that trend has started to increase again, points out renewed activity and pressurization in the hydrothermal system. So the strong correlation that we have between the CO2 emissions and the Fumarolic tremor suggests that they are both linked to changes in the underground gas flow and pressure. So the recent increase in these CO2 levels and the Fumarolic tremor suggest a reactivation of the hydrothermal system, possibly due to new gas influx from deeper sources. Could be a signal for escalating volcanic unrest. Figure 417 is an interesting one as well. It shows us the summary of CO2 accumulation and the emission mapping. So there were reports of possible CO2 buildup in underground spaces, in buildings and schools, cellars, in the Campi Flegrei area and around it. And that's why the local authorities have requested an assessment of the hydrothermal CO2 emissions from the ground. And as a result, a preliminary rapid response map was created to identify different areas of CO2 release. That's what we're seeing here, and that's important for the residents. So areas 1 and 2, there's direct measurements. It was measured using a gas accumulation chamber method, providing on-site emission data. Areas 3 and 4, urbanized zones with impermeable surfaces. These areas have significant human development with paved surfaces preventing direct CO2 measurement. But local evidence suggests known gas emissions in certain locations. And area 5, groundwater-based CO2 analysis on CO2-rich groundwater wells where visible degassing has been observed. So this presence of increased CO2 accumulations in these underground spaces and also ground level spaces has really potential safety concerns for local communities. And so they're trying to get ahead of that. So if we look at section 5, this is graph number 511, and 512 is the monitoring updates around the geogrid well. So since September 2020, scientists have been conducting monthly CO2 flux measurements at approximately 30 points in a centered area at the geogrid drilling site, that what we see in 511A. These recent measurements have been compared with the historical CO2 flux data from 98 to 2016 collected for the same area, that is figure 511B. And the key findings are in figure 512, the CO2 emission trends. They were at an historic low in August 2020, and the August 2020 CO2 flux measurement was one of the lowest ever recorded in the area with only 150 tons per day. But since then, guys, we have seen a gradual CO2 increase since 2020. October 2020, 800 tons per day. Early 23, 900 tons per day. February 2025, 1,000 tons per day. That is marked in red on the graph that you see there. And this is significant. If we look at the long-term context, 98 till 16, flux range 58 to 630 tons per day, average CO2 flux 250 tons per day. But already in 2016, levels were already showing an increasing trend, which has continued into 2025. So what does that mean? These emissions from the ground near this geogrid site have significantly increased. And guys, that aligns with all the other trends that we see that indicate an increased volcanic unrest at Campi Flegrei. So currently, 1,000 tons per day is the flux. It's one of the highest levels ever recorded. And that indicates a stronger hydrothermal activity and rising underground pressures. Of course, this doesn't mean we will see an eruption tomorrow. We don't know how high this can go until something happens, a phreatic eruption, an intrusion, or a bigger eruption. But the trend is concerning if we compare it with the 80s, for example. And we're creeping towards levels before the Monte Nuovo was created with the 1500 eruption. If we look at figure 521, we see where it's measured, but we also see how densely populated this area is. And we're looking at the thermal imaging monitoring at the Entn station. It is part of the permanent thermal monitoring network. It's called TIRNet at Campi Flegrei. So it captures infrared thermal images of the Antiniana area that lies between the southeastern outer slope of the Solfatara crater, the southern side of Peschiarelli near the geogrid drilling site. And if we look at the figure 522, what are the key findings? What is the temperature trend? The recorded maximum surface temperatures were analyzed using an algorithm, and the long-term trend, that's the red line, was determined using this loss fitting technique again, which smoothes fluctuation out, makes a more even curve. And they have seen in February 25 a minor cooling. So temperatures decreased slightly in the second half of February, returning to values similar to early January. But the long-term trend remains stable without significant changes. And so what is the general summary, guys? And then we're almost through with this monstrosity video. And I hope that you're all still here with me, that you don't have a caffeine shock from all the coffee, that you're still here and watching this. So the general summary of the volcano's status in February 2025, and that is important because now we have another escalation. The events leading up in February were leading up to this March swarm with the 4.4. We had 1,813 earthquakes in February alone. Strongest quake was magnitude 3.9. We had two of those. Most quakes occurred between Pozzuoli, Agnano, Solfatara, Peschiarelli area, Bagnoli, and the Gulf of Pozzuoli. Shallow depths, mostly in the 3-kilometer range. Ground deformation since August 2024. Uplift rate was 1 centimeter per month, but during the February seismic swarm, 1 centimeter in the most deformed area. And now uplift decreases rapidly, moving away from the caldera center. This is interesting. And the recent trend in the past 15 days, the uplift rate has first increased to like 15 millimeters per month. It's now at 3 centimeters, has doubled again. Total uplift at the right station since November 2005, 1 meter 40, 22 centimeters since January 2024. And also infrared cameras at Solfatara and Peschiarelli show stable surface temperatures Slight temperature decrease at the Agnagno station. Mobile thermal cameras and drones confirm stable temperature trends across Campi Flegrei. The gas monitoring, the geochemistry, Fumarolic composition and gas parameters confirm long-term heating and pressurization trends. Going like that. System peaked in July 2020, cooled in early 2022. Heating resumed then, and it's still ongoing. CO2 flux at Solfatara high, 5,000 tons per day. So everything remains elevated, suggesting that this ongoing hydrothermal and magmatic activity is not stopping, it's further increasing. The ground underneath continues to get pressurized. So if the uplift would accelerate further, this could increase the risk also to see stronger seismic activity or even further changes in the hydrothermal system. So they said we could see a 5.1. That's what everyone's so worried about, because the head of the civil protection has said, if we see a 5.1, we're counting the people that we lost, right? And then he got really the shizzy hit the fizzy for him when all the builders and developers that want to build right at the Solfatara crater, multi-million or even billion-euro project, they said, you can't say that, right? I think that might have changed now after the 4.4. And the damages are higher. People are injured now. Floors have collapsed. So hopefully something will change. They should, at least with their new alert levels, change it to dark yellow. Although I would prefer to call it light orange, because that's what it is, right? So we will have to see, guys. I hope you liked what I did here. 6 days. I'm exhausted. So leave it a like, share it with your friends, and leave a comment and tell everyone to watch it until the end. Because the risk with a long video is always if people only watch it like for 10% or whatever, the algorithm like kicks it out. So thanks for watching. For the ones that are still here, if you want to further support the channel, click the join button, become a monthly supporter of the channel as a channel member, and you're getting something for it. Check out my playlist for the channel members, and or both buy me a coffee at my buymeacoffee.com/silky site. I had to take a little bit of a break because Santorini and the volcanoes kept me so busy, but I will answer everyone's message who bought me coffee with a video message very soon. I'm waiting for a nice day. I like to take the computer outside and sit in the sun, have the dogs out in the sun, and then I'll do that. So wait for that. I haven't forgotten to do that. See you very soon, guys. Bye.